Kia ora Year 12 and Year 11. This is an AS question from the November 2018 set of papers. It's a coordinate geometry and calculus question, and it goes like this. We've got a diagram that shows us the graphs that go with two equations. So we've got a cubic, which is this one here, and then we've got a linear equation here, so y equals 5x. And the intersections are at the origin and up here at point R. But we're interested in point P. So point P lies on the line y equals 5x, and the x-coordinate of P is t. And point Q is also on the graph. Point P lies on the curve, and PQ is parallel to the x-axis. So the first thing we're going to do here is find the coordinates of those 2 points, because we have to express the length of PQ in terms of t, and we need to simplify our answer. So let's start by looking at that equation of the cubic. I'm going to expand that out, partly because I've read the next part of the question, and to find a maximum value, I'm going to want to have this in expanded form so that I can differentiate easily. So y is equal to 9x minus x cubed. Now at point P, the x-coordinate of P is t. So point P has the coordinates t, and then 9t minus t cubed. What about point Q? Well, point Q is on the curve, and PQ is parallel to the y-axis. So what that means is we know the x-coordinate here is t, and so the y-coordinate is going to be 5t. And that's because the equation of that line is simply y equals 5x. Now we need to find the length of PQ in terms of t. So PQ is going to be 9t minus t cubed minus 5t. Right? It's just the difference in the y values because the x values are the same. We need to simplify that, which gives us 4t minus t cubed. So that's the first part of the question done. Next, we need to find the maximum value of the length of PQ. Right, so we're looking for where along here am I going to get the biggest distance. So let's start by setting up f of t. So f of t is that vertical distance, which is 4t minus t cubed. To find a maximum, we differentiate and we set it equal to 0. So we get 4 minus 3t squared, which must equal 0 for a maximum. So solving this gives me 3t squared equals 4. T squared is equal to 4 over 3. Now this equation has got two solutions. T is equal to plus or minus the square root of this, which is plus or minus 2 over root 3. But let's just go back and have a look and see whether both of those make sense. Now they don't, right? We know that t needs to be positive because it lies between the origin and point R. So we can reject the negative 1 because t has to be positive. And now we need to take this and substitute it back in to my expression for the distance. Giving me 4 times 2 over root 3 minus 2 over root 3 cubed. And we're going to get an exact value for this. This is nice surds practice. So we've got 8 over root 3 minus 8 over 3 root 3. Getting a common denominator gives me 3 root 3 here. 24 take away 8, which equals 16 over 3 root 3. Now I think that answer's okay, but it would be nicer if we rationalised the denominator. So I'm going to multiply by root 3 on root 3, giving me 16 root 3 divided by 9. So there you go, some nice little bits of calculus and coordinate geometry in there. Remember, the reason that we could say that the distance PQ was just the difference in the y coordinates was because these x values were the same. Usually, to find the distance between 2 points, I need to use Pythagoras' theorem, which will be something in this form. Okay, but in this case we had a much simpler case because it was a parallel to the y-axis. Thanks for watching. leave me any comments or questions, or let me know if there are any particular AS questions you'd like videoed.